Hello children, I hope you all are well. Today again we are going to continue same chapter, that is chapter 2, physical quantities and measurement, part 4. Now our very first topic is children, hydrometer. Before starting hydrometer, do you remember that I have already taught you about relative density and relative density bottle, that is known as your RD bottle? Yes or no children? Now this RD bottle and hydrometer, both these instruments are used to measure the relative density of liquids. But in case of RD bottle, we apply the formula also of relative density, okay, for finding the relative density of the liquid. But here in case of hydrometer, we can directly determine the relative density of the liquid without applying the formula. So what is this hydrometer? Hydrometer is an instrument which is used to measure the relative density of liquids directly. It is usually made up of glass. This part is your hydrometer, okay? It is usually made up of glass consisting of the cylindrical stem and a bulb weighted with lead or mercury shots. You can here see lead or mercury shots. Yes or no children? This black one. So this hydrometer has two parts, cylindrical stem and a bulb attached to it which has a shots of lead or mercury to make it float upright in a particular liquid, whichever is liquid relative density we need to determine. Now the liquid to be tested is poured into a tall jar and hydrometer is gently lowered into the liquid until it floats freely. Now the liquid whose relative density we need to determine, that liquid is poured into a tall jar, and then what we do? Then gently we immerse the hydrometer in that liquid until and unless it floats itself freely in that particular liquid. Okay. Now the point at which the surface of the liquid touches the stem of the hydrometer is noted. Now how do we determine the relative density of the liquid? The point at which the surface of the liquid touches this cylindric stem of this hydrometer, that point is noted, and that point gives the relative density of the liquid. Okay children, so what we are doing here, first of all we are taking a liquid whose relative density we need to determine in a tall jar, and then what we are doing, then we are simply lowering the hydrometer in that particular liquid. Now as soon as it floats freely by itself, we record the reading at the point where the surface of the liquid touches the stem of the hydrometer, and that reading or that point gives directly the relative density of that particular liquid. Now one more line is given here, that lower the density of the substance, further will the hydrometer sink. Yes or no children? If the density of this liquid will be less as compared to this hydrometer, so what will happen? This hydrometer will sink further in this liquid. That is the reason here it is given that lower the density of the substance, further will the hydrometer sink, because you know that if the density of this liquid will be less, then what will happen? If the density of this liquid will be less in comparison to this hydrometer, then what will happen? This hydrometer will further sink inside that particular liquid. Now a special type of a hydrometer is used children for testing the purity of the milk. That type is called your lactometer. That particular hydrometer is named as lactometer, which is used to test the purity of the milk. I suppose children I am clear to you about this hydrometer. So hydrometer, once again I am repeating to you that hydrometer is used to measure the relative density of liquids. It consists of two part cylindrical stem and a bulb which has a shots of lead and mercury. You can see this black portion. It has a shots of lead or mercury to make it float upright in a particular liquid. Okay, then the liquid whose relative density we need to determine, is pour inside a tall jar, tall cylindrical jar, and then gently we immerse this hydrometer or lower this hydrometer in that particular liquid until unless this hydrometer itself floats freely inside that liquid. And as soon as it floats itself freely inside that liquid, we record the reading where the surface of the water touches the stem of the cylindrical stem of this hydrometer. Okay. Now one more thing, children. Here with the help of this hydrometer, we can directly determine the relative density. Reason, it has a paper scale. You can see this graduated. Graduated means it has a marking. Okay, graduated scale, paper scale inside that stem, which help us to record the relative density of the liquid directly. And the special type of a hydrometer which is used to test the purity of the milk is called your lactometer. I suppose, children, I am clear to you? Yes. Now next topic is flotation and sinking. Now children, here this first paragraph is very important in flotation and sinking. Suppose if we place a solid over a liquid, you know that it may sink or float depending on their density. Yes or no, children? Suppose there are two liquids. Okay. And we are taking same object. Okay. Suppose in this, if we place this object A on this over the surface of this liquid, so here this liquid gets sink inside that particular liquid. This object gets sink inside that particular liquid. But suppose if we place same object A in another liquid B, so what we find that here the object does not sink but it floats over the surface of the liquid. So what is that reason? Reason is that in first case, this is your first case, here the density of this substance A is, what is there? The density of the substance is more than the density of the liquid. Therefore, what happened? This object gets sink inside that particular liquid. Whereas in case 2 or second case, here the density, if we take the same object A over another liquid, okay, so here the object is not sinking but it is floating. Reason, here the density of the substance A is less than the liquid, less than this particular liquid, and hence it is not sinking, it is floating over the surface of this particular liquid. Same thing is given here, children, that when a solid is placed over a liquid, it may sink or float depending on their densities. If the density of the solid is less than the density of the liquid, the object will float, as is we have seen in case first or case 1. And if the density of the solid is more than the density of the liquid, the object will sink in the liquid. Sorry children, in case first or in case 1, I have told you about sinking, that if the density of the object is more than the density of the liquid, then that object will sink in that liquid. And in second case, I have told you that if the density of the object is less than that particular liquid, then that the object will float on that surface of the liquid. So this flotation and sinking depends upon the density of the object or substance. If you are placing any object over the surface of the particular liquid, then that object will sink or float. This depends upon the density of that object. If the density of the object or that solid is more than the density of the liquid over that you are placing, then that object will sink. Okay. And if the density of that object is less than the density of liquid over which you are placing, then that object will float over the surface of the liquid. So this is all about flotation and sinking. One example I will take here. Suppose, for example, a ball made of iron sinks in water. Reason? Because density of iron is more than that of water, or you can say iron is more denser than water, but floats in mercury. Now same iron ball if we place in water, then that ball gets sink in water. But if that iron ball we take on the surface of mercury, then there it will float. Reason? Here it will sink because here the density of the iron ball is more than the density of the water, and here it will float. Reason? The density of iron ball is less than the density of mercury. Okay, or you can say mercury is more dense than the iron ball. That is the reason a ball made of iron sinks in water but floats in mercury. Similarly, ice floats in water but sinks in kerosene. I suppose children I am clear. Ice floats in water means density of the ice is less than water. So therefore ice floats on water. Whereas in case of kerosene, if we compare the density of the ice with kerosene, then in case of kerosene, the density of the ice is greater than that of kerosene, and hence in case of kerosene, if we place the ice over the kerosene, there it will sink in kerosene. So children, I suppose I am clear to you. Now coming to applications of flotation, you can see here many applications are given here. That relative density of candle wax is 0.93 and hence the object made of wax float on water. Yes or no? Since here the relative density of the candle wax is 0.93, which is less than the relative density of which is less than the density of the water, and hence this candle wax will float on the surface of water. Similarly children, here it is given next application, that unlike river water, sea water has lots of salt dissolved in it. So sea water is denser than river water, therefore it is easier to swim in sea water than in river water. Yes or no children? You all know that sea water is salty. Salty means lot of minerals and salts are dissolved in it, or the concentration of salt in sea water is more as compared to river water. Therefore we can say that sea water is more denser than river water. Yes. So that is the reason it is easier to swim on sea water as compared to river water. There the object, if we are going to throw any bottle over the surface of the sea water, so in sea water it will float. Reason? Sea water is more denser than that bottle. Okay, whereas in river water there is a possibility that if the water is suppose it is a pure water, then there is a case that it depends upon the density of that bottle also. So if that bottle is more heavier than that water, so there it may sink. Okay, and if it is lighter, it may float. So that is the reason here it is given that since sea water is more denser than river water, sea water में concentration of the salt ज़्यादा है, वो denser ज़्यादा है, इसीलिए sea water में swim करना easy है because object will easily float over the sea water as compared to river water. Now one more application is given. The density of ice is less than that of water. Okay, density of ice water की density से कम है. So that is the reason ice floats on sea water. Yes or no? Density of ice is less dense as compared to water, and that is the reason icebergs float on sea water. Now, since river water has lower density than sea water, a ship loaded with cargo submerges more in river water than in sea water. So the weight of the cargo has to be limited to prevent the sinking of the ship in river water. I think children, I have explained you this point in previous application only. Okay. Now for the same reason, all the ships have marking on their hull. Hull, what is this hull? Suppose this is your ship. The lower deck is known as the hull, and it has the marking. There is a marking at the lower deck or over the hull. What is that marking? That marking is called your plimsoll line, which help to prevent the ship for submerging more inside the water. Okay, see here, all the ships have marking on their hull to indicate the level up to which they can submerge safely in a particular sea or river, and these markings are called plimsoll line. Plimsoll line. Okay, I told you that in ships, lower deck of the ship has the marking, that lower deck is also called hull, and here it has a marking called plimsoll line, which help to prevent the ship further inside the sea water, or you can say it is a safety line which indicates that up to which point ship has to submerge in a water, sea water or river water. Okay, and that line is called as plimsoll line. If the ship is loaded beyond its plimsoll line, it runs the risk of sinking. So children, all the applications, I suppose it is clear to you, and do read it by your own also, it will be more clear to you. Okay, and this point is also clear to you that sea water is more denser than river water. That is the reason it is easier to swim in sea water as compared to river water, because sea water helps to float the object. Sea water helps to float the object. It will the object which is lying over the sea water, it will float. Reason, because sea water is more denser. Okay, and whereas there is a possibility that if any object is lying on the river water, it may sink or may float depending upon the density of that object, depending on the density of that particular object. Now children, variation of density with temperature, this is our next topic. Now you all know that generally matter expand on heating and contracts on cooling. This you already know in you have studied from class 7th, that matter, when we heat any matter, it expand on heating. Generally it expand on heating and contract on cooling. Yes or no? For a substance having a fixed mass, the density will change if the volume of the substance changes. It means that if the volume of the fixed mass of substance decreases, its density increases, whereas if the volume increases, its density decreases. Now children, I will explain you this in very simple manner. You all remember formula for density, that density is equals to mass upon volume. So is there any relation if we take mass fixed or if we take mass constant, there is no change in mass? So can we find any relation between density and volume? Yes. What we can find? That if we write density rho is equals to mass upon volume, and if we fix our mass is not changing, then there is a relation between density and volume? Yes. What you can find, that here density rho has a inverse proportion with the volume. Yes or no? If both the things have a inverse relation, how come you can say that they have a inverse relation? Means if you are taking mass fixed, mass को अगर आप fix कर दे रहे हो, mass is not changing, then this your density and volume both are indirectly they are related. Okay, they have an inverse relation. How? Suppose your volume is increasing, then what will happen? Density will decrease. Same way, if your volume is decreasing, then indirect relation is here, density will increase. I can write it clearly here, that your density, you know the formula, density rho is equals to mass upon volume. And suppose if mass is fixed, mass is not changing, so can we relate density and volume? Yes. What is there? Here density is inversely proportional to volume. Yes or no? Inverse relation is there. If your volume is decreasing, volume कम हो रहा है, तो डेंसिटी क्या होगा, ऑपोजिट होगा, डेंसिटी बढ़ेगा, इंक्रीज करेगा. सेम वे if I write that density rho is inversely has an inverse relation with volume, and if you same way if I say that volume is increasing, तो यहां पर क्या होगा, density will decrease. Same thing is given here. If the volume of the substance changes, it means that if the volume of a fixed mass of a substance decreases, volume of a fixed mass of a substance decreases, its density increase, whereas if the volume increases, its density will decrease. Yes or no, children? Have you understood this thing? That suppose if we are heating any matter, or if we are suppose we are heating any substance, so what is happening here? You already have studied here that generally matter expand on heating and contract on cooling. So on heating, if the matter is expanding, so what does it means? Its volume is increasing. अगर हम मास को फिक्स रख दें और किसी मैटर को हीट कर रहे हैं, so what is happening here? Volume will increase, and if volume will increase, then what will happen? That object will become less denser. Yes or no? And since you know that density rho is equals to mass upon volume, if mass is fixed and volume is increasing, you know that density and volume has the inverse relation. तो अगर वॉल्यूम बढ़ रहा है, ऑब्जेक्ट एक्सपैंड हो रहा है हीट करने से, तो क्या होगा, ऑब्जेक्ट विल बिकम लेस डेंसर एंड हेंस डेंसिटी विल डिक्रीज. ओके. सेम वे if we are cooling object, if we are cooling any object, तो then object will compress, volume कम होगा. Okay, volume कम होगा, then it means object will become more dense, and hence we know that density rho is equals to mass upon volume. Mass is fixed, volume कम हो रहा है, तो density क्या हो रही है, बढ़ रही है, और density will increase. Same thing is given here also. Now since children, as you know that solid do not undergo significant expansion or contraction, reason, as you know that in solid molecules are closely packed in a given volume, and hence there is no more changes, no more significant change when we are heating solid. Okay, same thing is given here, that solid do not undergo significant expansion or contraction with the change in their temperature. Solid में बहुत ज़्यादा changes नहीं होते. Reason, because in solid molecules are very closely packed, and hence we cannot see much more effect in solid of expansion and contraction. The intermolecular forces are very strong. But if we talk about gases and liquid, there we can find significant changes. See here. However, in case of liquids and gases, there is a large change in their volume. Because why there is a large change in their volume? Because here the molecules, if we talk about liquids, so in comparison with solid, the molecules are not much tightly packed. Yes or no? So here if we heat liquid, it can easily expand, and hence if it will expand, then volume will increase and then density will decrease. Okay. So there is almost no change in its density. However, in case of liquids and gases, there is a large change in their volume even with the small change in temperature. As a result, when the liquid or gas is heated, its density decreases, and when cooled, its density increases. The difference in the densities of different layers of liquid or gases set up convection currents in them. So children, as I already told you that if you know the formula, that density rho is equals to mass upon volume. If we are fixing the mass, we are not changing mass, and if we are doing any change over the volume, suppose if we are increasing the volume, then since volume and density are both have a inverse relation, okay, indirectly related, so we can say that if the volume is increasing, then density will decrease, because if there will be expansion, okay, so that object will become less dense and hence the density will decrease. Same way, if we are decreasing the volume, then what will happen? Density will increase, and we do not find significant expansion or contraction in case of solid. Reason? Because in solid, molecules are more closely packed, okay, so hence we cannot find any significant changes in case of solid with the change in temperature. अगर solid पे temperature का बहुत ज़्यादा effect temperature से नहीं होता है. But if we take the case of liquids and gases, there we will find a much large change as compared to solids. Reason? Here molecules, if we talk about liquids, then in case of liquids, molecules are much less tightly packed, and therefore there can be easy you can find easily there will be expansion in their volume, and hence if volume will expand, so what will happen? Density will decrease. Same way in gases, the molecules are further more apart in case of gases, and hence with the change in temperature, there will be again expansion in the case of gases in their volume, and hence the density will decrease. So I hope children I am clear to you. Okay, so this volume and density has the inverse relation. Volume बढ़ेगा तो density कम होगा with the effect of the temperature. Same way, अगर volume क्या होगा? Volume घटेगा, there is a decrease in volume with the effect of temperature. Okay, so what will happen? If there is a decrease in volume when we cool the object, okay, so volume कम होगा, so density क्या होगा? बढ़ेगा. So I think children I am clear to you, and if you have any doubt, you can ask me. Thank you children.